Okay, in this word problem we have Annabeth, who drives 45 miles to work. If she increases her average speed by 5 miles an hour, the time it takes her to drive to work is decreased by 6 minutes. Find her usual average speed. Okay, so this is a, a related rates problem where we're trying to relate two rates. So distance is equal to rate times time. So rate is equal to distance over time. Alright, so distance equals rate times time. So we're going to use that expression, that relationship, to come up with two different equations. Alright, that's the first thing I noticed. The second thing I noticed, really important here, alright, is that they give a speed in miles per hour and a time in minutes. Okay, when you are relating different units of measurement, make sure that they're all in the same units. So if we're talking about time, either put it in hours or put it in minutes, but don't cross them. So we're going to put our time in hours because it's more common to get, like, it just makes more sense to have a rate in miles per hour instead of miles per minute. So we're going to, instead of using, we're going to keep 5 miles per hour, but 6 minutes, we're going to do 6 over 60, and that's going to be now 1/10 of an hour. Alright, so 6 minutes is 1/10 of an hour. Okay, so now let's make our table to help us set up our equations. So the tables always go distance, rate, and time, and then we have like two different rates that we're relating. Alright, now the rates that we're going to be relating, well, let's read it. Annabeth drives 45 miles to work. If she increases her average speed by 5 miles an hour, the time it takes her to drive to work is decreased by 6 minutes. So find her usual average speed. So we'll make one row like her usual commute to work, and then the other one like her fast one, where she speeds up. Okay? So she drives 45 miles to work. That doesn't change whether she drives her usual speed or her fast speed. So we're going to put 45 there and there. Okay? And we're going to make sure that it's in miles. And it is. Because our rate is going to be in miles per hour, because that's given like that, so our time has to be in hours. Alright, so these columns have to be measured in the same units. Okay? Now her usual rate is what we don't know. Okay, because it says find her usual average speed. So that last sentence will usually help you define your variable. Alright, we don't know her usual average speed. So we're just gonna call that R. So R is her usual average speed. That's what we're gonna look for. Alright, so when she goes fast, that's when she increases her average speed by 5 miles an hour. So her fast speed is gonna be whatever her usual speed is, R, plus 5 miles per hour. Okay? And then the time, alright, so we have another variable. Alright, that's why we have two equations here that we're setting up, because there are two variables. First variable is rate, her second variable is time. Distance we know. For all these problems, distance, rate, and time, you're going to always know one of them and not know two of them, but be able to set up two equations based off what they give you. Alright, so distance we know, rate we don't know, time we don't know, but we can relate them. So it says, alright, the time when she drives 5 miles faster, the time it takes her to drive to work is decreased by 6 minutes. So we don't know what her usual time is, but we know when she drives faster, her time is decreased by 6 minutes, which is the same thing as 1/10 of an hour. Okay? Alright, and now we have a system of equations, because distance is equal to rate times time. So 45 is equal to R times T. 45 is also equal to R plus 5 times T minus 1/10. Okay? Now we have to solve this. Now you might think, alright, let me just set these equal because they're both equal to 45. But then you would have two variables. So instead what you want to do is take one equation, alright, maybe put T in terms of R. So now you have T is equal to 45 over R, and then plug that in right there. And then now we can just solve this equation. Either, I would just graph both sides or use the solve function. Alright, so when we type that in the calculator, and we solve for r, we get that the rate is either negative 50, which wouldn't make sense, or 45. Alright, and since we defined r to be her usual speed, that is our answer. Okay, so always make sure you're answering the question based off what it asked. It didn't ask for the time, it didn't ask for her fast speed, it asked for her usual speed. So we'll go 45 miles an hour.